Have you ever wondered what's behind the incredible power of a jet engine and how it manages to propel a massive airplane through the air? I mean, think about it. These engines are like giant superchargers strapped under each wing. But instead of just sucking in air and pushing it out, there's so much more going on. So let's dive into this curiosity. How does a jet engine actually work? Imagine you're blowing up balloons with your mouth. You take in some air, push it through your lips, and voila, out comes the balloon. A jet engine is kind of like that, but on an epic scale. Air enters the intake, gets compressed by spinning blades, mixed with fuel, and then ignited to produce a powerful burst of exhaust. But there's so much more to it than that. And here's the surprising part. The key to understanding how a jet engine works lies in something called ram pressure. Basically, the air that rushes into the engine compresses as it moves faster, giving the engine its initial power boost. Then, the hot gas produced by burning fuel is expelled at high speed, creating thrust. So, stick around because we're going to break down everything step by step and make sure you walk away knowing exactly how these awesome machines keep us in the sky. Subscribe if you want to know more about what powers your flights. So, here's the big secret most people don't know about jet engines. They work just like an everyday toy you might have played with as a kid, balloons. Imagine blowing up a balloon and then letting it go. What happens? It zips across the room, right? That's exactly how a jet engine works, but on an incredibly powerful scale. Inside the engine, there are these giant fans that suck in air from around the plane. That's step one, sucking air. Then just like you do with a balloon, we push some of that air into the back of the engine and mix it with fuel. This mixture is ignited. It's like lighting a small fire inside, causing an incredible amount of gas to explode outward super fast. And here's the surprising part. As this hot air rushes out of the back, it pushes against the surrounding air even harder, creating a kind of tiny explosion that propels the plane forward. It's just like when you blow up a balloon and let go. It flies across the table because of the sudden rush of air. So, in simple terms, jet engines generate thrust by expelling high-speed air out the back, pushing the plane forward in the opposite direction, much like how a cannon works. Pow! The cannonball goes one way, and the cannon itself moves backward. And here's the surprising part. A jet engine is made up of four main components. Let's break them down one by one. First, we have the compressor. Think of it like a giant fan that sucks in air from outside the plane and compresses it into a tiny space. This compression is crucial because it helps mix the air with fuel more effectively. Next is the combustion chamber. Imagine this as a blowtorch. Inside, fuel and compressed air are ignited, producing an incredible amount of heat and energy. It's like setting off fireworks inside the engine. After that, we have the turbine, which harnesses all that power. Picture it as a set of spinning blades that spin super fast because of the hot gases rushing past them. These spinning blades then spin another set of blades connected to the compressor and other parts of the engine, keeping everything running smoothly. Finally, there's the nozzle. This is where the magic happens to turn all those fast-moving gases into thrust. Imagine it like a garden hose. When you open the nozzle on that hose, water sprays out with considerable force. The exhaust from the nozzle in a jet engine does the same thing, but much faster and much more powerfully. Together, these four components work seamlessly to make your plane fly. The compressor grabs air, the combustion chamber heats it up, the turbine turns all that energy into motion, and the nozzle shoots out those gases to move the plane forward with incredible speed. So now we've covered the four main components of a jet engine: the intake, the compressor, the combustion chamber, and the turbine. But you might be wondering, how do all these parts work together to get that plane zooming through the sky? Let's break it down. First, air comes in through the intake. It's like sticking your hand out the window of a moving car. You feel the wind rushing past. As the aircraft moves forward, this air is pushed into the engine at high speed and under pressure, kind of like sucking a straw really hard, but on a much larger scale. Next, as that air gets sucked in, it goes through the compressor. Think of this part as super strong fans that spin incredibly fast to compress the air even more. It's like squeezing a water balloon. You're reducing its volume and increasing its pressure. This high-pressure air then moves into the combustion chamber. In the combustion chamber, fuel is mixed with this highly compressed air. And here's the surprising part. This mixture is ignited by an electric spark, kind of like a small explosion. But instead of just making a bang, it creates a huge burst of hot gas. Imagine lighting a match in a giant pressure cooker. The steam and heat build up so much that when you open the lid, it whooshes out. This high-temperature, high-pressure gas expands rapidly through the turbine, a set of blades that spin at incredible speeds. It's like the blades of a windmill catching the force of the explosion. As these blades turn, they drive the compressor, pushing more air into the engine and starting the whole cycle over again. And voila! You've got a self-sustaining system where the expanding gas from the turbine drives the compressor to keep compressing air and igniting fuel. This process creates a tremendous amount of thrust, like an enormous fan pushing against the air, propelling the plane forward with incredible force. It's like having the strongest fan you can imagine, but instead of moving paper, it moves a massive aircraft. This cycle is what gives a jet engine its power and efficiency. And while it might sound complex, it's all about simple principles working together to do something amazing. And the good news for nervous flyers is that modern jet engines are incredibly efficient and safe, with multiple fail-safes and rigorous testing to ensure they operate smoothly and reliably, making air travel one of the safest modes of transportation. Imagine a jet engine as a super efficient machine. Think of it like a giant fan that not only blows air, but uses it to push the plane forward. The key here is efficiency. Every bit of air moving through the engine is either used for thrust or cooling. Modern engines are designed to get every last drop of energy out of the fuel, which means less waste and better performance. And what about safety? Jet engines have backup systems that work like a safety net. Imagine you're climbing a ladder, and each rung has an extra support just in case one fails. That's kind of how jet engines are designed. There are multiple layers of redundancy, backup nozzles, additional fuel pumps, and even emergency power units that kick in if something goes wrong. To make sure everything works perfectly, every engine is tested to the nth degree. Engineers simulate turbulent weather conditions, push the engines to their limits, and monitor every tiny detail. It's like a car going through a rigorous tune-up before a big race. Everything has to be just right. So, when you're sitting in your seat, you don't have to worry about your engine letting you down. The engineers and manufacturers work incredibly hard to ensure that each component is tested, checked, and designed with your safety in mind. That's why modern jet engines are not only powerful, but also extremely reliable, making air travel one of the safest ways to get from point A to B. So, to answer our initial question, a jet engine works by harnessing the power of combustion to produce a high-speed exhaust that generates thrust. Think of it like a giant fire hose, but instead of water, you have superheated air shooting out at incredibly high speeds. This backward flow creates forward motion, propelling the plane through the sky. And here's the surprising part. Despite its seemingly simple concept, jet engines are incredibly complex machines. They involve precise control of fuel and air mixtures, sophisticated cooling systems to handle the intense heat, and advanced materials that can withstand extreme temperatures and pressures. The engineers who design these engines truly push the boundaries of what we can achieve. By understanding this basic principle, you now have a newfound appreciation for the incredible engineering that makes air travel possible. Jet engines are not just machines. They are marvels of modern technology that defy the laws of physics in the most elegant ways. And if you're anything like me, the more you learn about aviation, the more fascinating it becomes. If you'll never look at a plane the same way now, you know what to do. Subscribe for more explanations and insights into the world of aviation. Together, we can uncover the secrets behind how planes fly and why flying is one of the safest modes of transportation out there.